below shows 5 organic compounds represented by the letters A to E. Okay. 3.1. Is compound B saturated or unsaturated? Give a reason for your answer. We have CH3, CH3. So that's an alkane. So this is what it's going to look like. So this is definitely saturated. And the reason for that is because there are no double bonds, or we have single bonds only. So it is saturated. Only single bonds between the atoms. 3.2. Consider the boiling points of compounds A to E given in random order below and use them where applicable to answer the questions that follow. 3.2.1. Write down the boiling point of compound C. Okay, let's just arrange these first. Okay, so we are going to see, we have CH4, so we have A, B, C, D, and E. Okay, so from A to D, we have alkanes only, right? The only thing that is different is the chain length. So for A, we only have 1 carbon, for B, 2 carbons, 3, and then 4. So there is an increase in the boiling point of a compound with an increase in the chain length. So let's just say we know for a fact that E is going to be 78 degrees because that's an alcohol and there's hydrogen bonding there. So it will have the highest boiling point. And then CH4, it is going to have the lowest boiling point because we only have 1 carbon atom there. So it is going to be minus 162 degrees Celsius, and then followed by what? Minus 89. And then C, it is going to be minus 42. And then the last one is 0. Okay, that is going to be the order. 3.2.1. Write down the boiling points of compound C. That is going to be minus 42 degrees. 3.2.2. For E, that is 78 degrees. Okay. 3.3. Explain the difference in boiling points between compounds C and E by referring to the type of intermolecular forces present in each of the compounds. So an alkane only has the weak van der Waals forces, and then an alcohol has the weak van der Waals forces plus the hydrogen bonds. So we are going to say C has the weak van der Waals forces, and E has hydrogen bond in addition to the van der Waals forces. Okay. Hydrogen bonds are stronger than the van der Waals forces. Thus, the molecules of E require more energy to be separated. Okay. 3.4. Does the vapor pressure increase or decrease from compounds A to D? Fully explain the answer. Okay. So we can see that from A through E, the boiling point is increasing. Okay. It means that the vapor pressure decreases, because as the boiling point increases, the vapor pressure should go down. So the first thing we are going to say, the boiling point increases from A to E. So this means that thus the vapor pressure should decrease. Okay. And then we will say from A to E, there is an increase in chain length. Okay, from A to D, let me just say from A to D, because I'm comparing compounds that belong to the same homologous series or functional group. A to D, there is an increase in chain length, and then the boiling point increases with an increase in surface area, or you can say in the chain length. And then you know that E simply just belongs to alcohols, which have H bonding hence will have the highest boiling point. The 3.5. How will the vapor pressure of 2-methyl propane compare to the vapor pressure of compound D? Propane means 3, 1, 2, 3. And then on carbon number 2, I have a CH3 group. And then D is just a linear compound. So this means that the vapor pressure, okay, let's start with the boiling point. The boiling point of this right here, it is going to be lower when compared to the boiling point of D, because branching decreases what? The strength of the intermolecular forces. So it means that 2-methyl propane will require less energy in order for the molecules to be separated. So it will have a lower boiling point compared to D. And then we know that when the boiling point goes down, the vapor pressure should go up. So this one will have a higher than vapor pressure.